Hello, my name is Isabella and I will be your host for another mathematics video brought to you by RJ. I have a very interesting question for you today, but before I reveal it, let me ask you a few questions leading up to it. Obviously, 1 equals 1. What is 1 plus 1? 2. What is 1 plus 1 plus 1? 3. What is 1 plus 1 plus 1 plus 1 equals 4? Suppose we keep going. What is the sum of an infinite amount of 1? I bet you thought the answer was infinity. What if I told you that it equals 2? How is this possible? Let me show you. The Fibonacci sequence starts with 2 1s. Then each following term is the sum of the 2 previous terms. The Tribonacci sequence starts with 3 1s, then each following term is the sum of the previous 3 terms. Let's look at the ratio of consecutive terms in the Fibonacci sequence. The limit of the ratio of consecutive terms equals phi, the golden ratio. Suppose we keep constructing sequences in this fashion, where we start with n amount of 1s and each of the following terms equals the sum of n previous terms. Then let's look at the limit of the ratio of consecutive terms in these sequences. Is there a formula for this? This is the equation for any of the sequences we have been discussing. This series on the right-hand side can be expressed compactly as this. The summation can be expressed as this closed formula. Let's multiply each side by x minus 1. Now let's move the x to the n on the right side to the left side. Factor it out and multiply each side by -1. Now, let's divide both sides by 2 minus x. We can isolate n by taking the natural logarithm of both sides. So now it looks like, finally, we divide both sides by the natural log of x. We now have a closed formula for n in terms of x. But this is not exactly what we want. We want a closed formula for x in terms of n. So, what can we do? Here is the graph of n in terms of x. We want the inverse. We can graph an inverse by reflecting a curve over the line y equals x. Here is the graph of x in terms of n, which RJ calls the Fibonacci curve. Here are the values of the limits of the sequences we discussed. As we can see, when n equals 2, which is the Fibonacci sequence, the limit does equal the golden ratio. We can also see that as n goes to infinity, the limit goes to 2. How is this related to our original question? RJ calls this the infinite Fibonacci sequence, which starts with an infinite amount of 1s in each of the following terms as the sum of the previous infinite terms. Remember, the limit equals 2, and the limit is the ratio of consecutive terms in the sequence. We know that there are an infinite amount of 1s, so in must equal 1. This implies in plus 1 must equal 2. Therefore, the next term in the sequence must be 2. And by construction of this sequence, since all of these are 1s and there are infinitely many, then the sum of them equals 2. Amazing, isn't it? What a paradox. The only question left is, what is the closed formula for the Fibonacci curve in terms of n? I'll leave you with an easier question. What is the closed formula for the infinite Fibonacci sequence? I hope you enjoyed the video. If you did and would like to see future videos, please like and subscribe. Also, if you are looking for math tutoring, whether it be algebra, geometry, or calculus, please contact RJ, one of his social media profiles, Eternal Love Onk. Thank you for watching.